Okay, so I'll have whatever I can recorded, and I'll try to remember to show stuff to the camera. Okay. Um, so the goal here is to kind of give you a background in kind of two or three things. The first thing is like the remote control, like hobby, which then applies to robotics in some form of another. Okay. And then what we can do is just a quick demo in Inventor, but I'll probably have you do it on your computer because I don't have it on my Surface. But we can go through some stuff. So let me let's just kind of talk about. Oh, there we go. The fundamental. Okay, is it going to go? There we go. Types of any type of vehicle you could get. All right. They have drones, which this is a small scale right here. All right. This is from a company called DJI. They have boats. They have helicopters. They have surface vehicles, which could be monster trucks to whatever. And then they have airplanes. Okay. Now, if you notice, we kind of have like three aspects. We have surface vehicles, we have water vehicles, and then we have air vehicles. Okay. One thing that you don't have to worry about for robotics, but you do have to worry about that if there's anything flying in the air, is the FAA. So drone policy is very strict. Okay. So I know there's a few capstone students in electrical, or maybe one that's working on a drone. You really have to follow regulations. So in order for you to fly one, even if it's recreational, you have to pass what they call a trust exam, which is a very simple exam just to make sure you know the fundamental basics. Because you can't fly over 100 meters. You have to have visual line of sight. If you're driving first person view, FPV, you got to have someone with you so they can see the plane. And you also have to have a number on your drone. Okay. Unless it weighs under 250 grams, which this weighs 249 grams. Okay. You don't need the trust exam because this really won't hurt someone or a vehicle or whatever if it crashes. I mean, it still could, but not as much as something weighed over 250. Okay. So a lot of issues with airplanes, drones, helicopters, anything in the air, you got to be very careful with. And in order for you to make money by either taking photographs or flying and making videos and you're making money off those videos, you have to take actually the Part 107, which is your pilot license. So I'm studying for that, and hopefully in a year or two, I can be able to do that. Lucky for you, you're classified as the surface vehicle, which is a robotic, so you don't need to worry about any of that. But anytime I always do RC stuff, I want to remind that you have to kind of do that. Okay. We are getting the soccer drone, which is indoor in a cage, and you technically kind of can get away with a few things, but we still always have people do the trust exam because it's basic stuff you need to know, like how does the controllers, how does it fly, all the basic stuff are in that. So surface vehicles, they range, and I'll go to the next slide here. They have a scaling. So like this one right here, this is really tiny. This is like a 24th scale. Okay. Where this is called the stadium truck. Okay. This is a 10th scale. All right. So they make 5th scales, which are huge. Okay. Like these things are massive. I can pull my kid around with it. I did actually. And Some of these can, and I think I talk about it later, they could be battery powered or gas powered. For robotics, it's all battery powered because it's so much easier. You're indoors in a cage. You don't want to smell the fumes. But there are gas that you can get for these vehicles. Typically, 24 scale is good for indoors. And bigger ones, obviously, you got to do it outside. So, and again, same with robotics. Like, I don't know the scale on this. This might be 18th scale, probably, depending on. But really, you can't. They don't make big robots like this, but they make stadium trucks. They make monster trucks, and that's how they compare it based on that. Okay. Now, this kind of goes along with robotics too. Is do you just buy a full ready to run RTR or an ATR almost ready to run, or a kit, and you build it from that? Okay. Now, a lot of the times, the ATRs almost ready to run don't contain maybe a transmitter and a receiver, which I'll talk about later, like what those are. So you may have to buy those. Kits, majority of the time, you have to put everything together from scratch. You have to paint, and there's actually a certain way you paint. You actually don't paint, you don't spray paint on top. It's a clear body, and so you actually spray paint underneath because you don't want it to scratch when it hits something. Okay. So you're actually, when you paint something, you're thinking in reverse, right? Because if you paint it all black, then this is going to be all black. So you have to tape off, paint it, take the tape off, and then paint where you want. Okay. So it's in layers. They typically do not have a battery or a charger. Okay. Sometimes the RTRs or ATRs will have a battery and a charger, but sometimes it all depends on the company. Okay. Now, so ground vehicles, which again kind of goes with robotics, you can have a vehicle that is two-wheel drive. So this one right here is two-wheel drive. So the back is where the motor is housed. And there's no shaft from the back to the front. Okay. So these wheels just spin freely. Okay. This is two-wheel drive. You also make four-wheel drive. In robotics, if you wanted to, you could make a vehicle that has four wheels that are spinning. It would be four-wheel drive. Typically, you could have like a gearbox system in there to transfer that energy throughout.
A lot of it is like tangential drive.
Yep. Or yeah.
With like gears on between the wheels.
Yep. Yep. So like, so it all depends. Now, the reason I put this in as well is a lot more components in a four-wheel drive. So if you're making a robot that has a lot more components, it's going to have probably more issues troubleshooting to get it to work and more parts to possibly break. So you want to be careful with that. Here's a picture just to kind of describe, like here's electric on the left. Where is my mouse? Right here. So it has a battery and other components, which I'll go through here in a second. And then over here is what they call like nitro or gas. It actually has a tank. It has an actual engine. Okay. And everything you need for it. Okay. Typically with gas, there's a servo, which is basically, I'll grab it right here. So this is a servo. Okay. This thing will rotate back and forth, and that can adjust how much fuel is going into the tank. Okay. Servos are also used for steering. All right. Or what you could do is like, you think about like a tank. I go back to this one. Say I didn't have a servo in here to turn back and forth. I could possibly control it where this motor spins, this one wheel, and then it would rotate, it would spin to the left if this one didn't spin. So you could assign sides if you wanted to, if you didn't want a servo to control it. That's kind of how these robots work. Is one wheel will spin, or actually one will spin one way and the other one will spin backwards. Okay. Now, off to components. There's a lot of information in here, but pretty much the basics are as follows. So say you have a robotic kit here, or an RC car. You're going to have a chassis, which is like the outside casing that holds all of the components. Okay. You got the wheels, and the wheels could be different compounds like rubber, or they could have different treads on them so you can grip wherever. But you will also possibly have a servo for steering. You will have a receiver, which I don't know if I have right here. Let me show you this. There's one in there. I can do this one. Actually, let me pull it out. So this right here, piece right here where you connect wires is a receiver. So that's a receiver. And then you could have a transmitter. Okay. So a lot of the times this is called TX and that is called RX. And you could get transmitters and receivers that have multiple channels. So this one actually has 6 channels. Okay. So like up and down, left and right, up and down, left and right. And then you have these top buttons up here to make 6. Okay. And you just have to figure out which channels correspond to which buttons on here. Okay. Now this is more of an airplane kind of style transmitter, where typically on a ground surface, you can get something that looks like this, where you have the throttle and the steering mechanism right here. Okay. But it all depends on kind of what you're comfortable with and what you want to use. Okay. Motors. It will have motors. So these are smaller motors in the robotic kit, but you could also get this huge motor right here. Okay. And it's usually connected to what they call an ESC, electronic speed controller. Okay. So anytime you have a motor, you need a speed controller, because that's how you control the speed to the motor, or the RPMs. Okay. And these motors, there's a couple different types. There's brushed and there's brushless. Okay. Brushed uses what they call brushes, and there's a mechanical component as it rotates, it connects. That's how you get it to work. Where brushless uses pretty much 3 wires and kind of a timing mechanism, and it doesn't have brushes, so it doesn't really wear out most of the time as bad as brushed motors. Okay, because the brushed motors will always constantly rub. All right. So, however, we use brushed motors when you need like instant movement or high torque, because sometimes these will take a second to recognize where the timing is for the sensors. Okay. So you have a transmitter, receiver, servos, electronic speed controller, motors, the chassis. You could also have like shocks if you wanted to, or suspension systems. And then the last thing is batteries. And I think I go through, we went through the motor types. So again, these yellow things are brushes, and this is kind of how the contact works. Here is your brushless. It kind of uses like some sort of sensor timing mechanism. But let's get to batteries, because batteries are very important that you know everything about them. Okay. So there are 2 main types of batteries that we use. Okay. These batteries right here, These are called nickel metal hydride batteries. And you can have 5-cell, 6-cell, 7-cell. This is actually a 7-cell. So there's actually 7 of these batteries that look like this. They're like a C battery. There's 7 of them in here. That's why it's a 7-cell. Okay. You could charge this up to 9.6 volts for this 7-cell. Okay. I believe it's like 1.5 or something for each cell roughly. Okay. These are the safest batteries to kind of charge and discharge and charge and discharge. Okay. They, as you drain them, they slow your robot down so you know that it's drained, and then you could charge this cell right back up. Okay. They're safe. The other batteries, these with 2 leads typically now, some are newer, which only has 1, but there's sensors in here. These are called lithium polymer batteries, LiPo batteries. And these pretty much are used in the robots because they produce a lot of, they're constant power for the entire time. Okay. And they don't really decrease because you don't drop them below a certain value. Okay. So this right here has what they call a balance lead, this right here, and you need to charge each cell in these LiPos separately. All right. Because you typically don't want to charge this plug, the big plug, because you don't know if you're putting voltage to one cell or the other. So your battery could read, for example, this is a 2-cell. When it's fully charged, it should be 8.4 volts, roughly 4.2 volts in each cell. But if you don't use the balance lead, you could have 6 voltage in one cell and 2.4 in the other. And that's not good at all. This will swell, and it could, as it's charging, explode or catch on fire. Okay. So you always want to balance charge these, and that's pretty much what you're using in your robots. Yes.
Why do they have?
So this is, so when you charge, you use this, but when you discharge, you only use this one. Yes. Yes. So when you hook it to the ESC to get power, that's where these power leads come from. Okay. They make 2-cell, they make 3-cell, they make 4-cell, and then say you wanted 8-cell, you would do 2 4-cells in series. Okay. Now, when you charge these, typically you always want to put them in a LiPo bag in case something happens, or some sort of container, and always store them. So typically I try to store them in a metal cabinet, but we do have a yellow cabinet that's fireproof down in the other lab where we should be storing all of these batteries. Okay. Because you never know what's going to happen. And I always check. So with LiPo batteries, when you charge them, you want to use them. Okay. Because they kind of have memory. If they're fully charged, they don't like to be fully charged all the time. It just doesn't do good with the cells. So you should usually discharge them to a nominal voltage, which is about 3.8 volts per cell. Okay. So some battery chargers, which I'll show you a charger. So here is a battery charger, and it has the main plug and the balance lead plug, okay, for the LiPo batteries. Some chargers will actually be able to discharge these. So you can discharge them to storage capacity, okay? If you don't, they don't like it, okay? And the other important thing is you never want to drop a cell below 3.2 volts, because again, that starts to make the cell expand and just not work right. Okay. So you never want to discharge below 3.2 volts, and you never want to charge it above 4.2 because it just won't. So LiPo batteries are really nice, but you got to be careful charging them. Some new companies now eliminate both of these. They have one plug with a sensor in it that plugs into a special charger, and it knows everything. It's actually really nice. They're a little bit more money. We're slowly converting to that way for all these batteries. So again, batteries. Now, with batteries and connectors, I talked about chargers. There are so many different types of connectors. So these that look like this, these are Dean's connectors. Okay. You have, actually, I don't even know what these connectors are called off my head right now. These little red ones that are on your, but they're called something. All right. You have EC5 connector, XT20. There are just so many different brands that you got to know, okay, I'm using that. All right. Or what you can do is I like to use Dean's. So I cut the wires and then solder on Dean plugs. Okay. Now, the reason why there's different sizes, do you see how it says EC5 and EC3? Those allow, like the bigger ones will allow more current to go through. Okay. So some of these wire, like this wire right here, I think is probably 16 gauge, I'm guessing. All right. Where the battery like this is probably 12 or 14 gauge. Actually, this is 12 gauge and this is probably 16 gauge. That means that you're going to have more current going through these thicker ones. So you want to make sure that this connector will hold that current, okay? Because on an RC car, you can get up to sometimes 30 to 50 amps coming out of a battery. So you want to make sure your wire size is big enough. On these robots, I don't think you'll ever reach probably 10 amps going through here. So you should be pretty safe with the size wires that are in these robots. Okay, that's where I talk about like the wire gauge and rating. Okay, so typically like 10 gauge will hold up to 40 amps. Okay, so you want to make sure you have the right gauge for that. Just a quick reference on maintenance, like make sure you have the right tools because some screws are Phillips, some are hex, some are metric, some are US. So you want to make sure that you have all of the tools that you need for that. These are kind of the fundamental like websites. And I figured like wherever you're going to go, like you can go ahead and buy parts from surface vehicles to drones to planes to boats or whatever. Okay. Just figured I'd have a kind of a complete thing. And then don't worry about that. Just kind of my thing. So that's a general idea of the fundamental basis for RC hobbyists. Okay. Questions before I move on? Okay. All right. Let me go now to kind of fundamental robot things, which are kind of very similar, but a little different. So now we're dealing with robots. Okay. And again, you could buy a kit, all right, that has all the parts and then you assemble it. Or typically you can make your own by 3D printing. Okay. So basically you can download, like this is like the Viper. So you could download the parts from a 3D printing website and then 3D print it and then buy the components. And that's what I did with this white one here is we 3D printed the chassis, right? And then I ended up buying motors, brushed motors that would fit the holes, bought an ESC, and this ESC, I could take out a little bit, and I'll show everyone, actually has 2 motor hookups, okay? And you can program that ESC to control each motor or do whatever you need, okay? Now, you could actually use 2 different ESCs with 1 motor plug, and later I'll show you how you can add that to the receiver and do it correctly, Okay. So this ESC I bought because I had two motors. It was easy. And what you need to do is you actually have to cut wires, strip them, and actually solder the wires on there. Okay. Um, and I would highly recommend, if you don't know how to solder, come grab me or grab someone that does, because that's a very useful tool. Okay. Would you say? Okay. So soldering is essential. I've saved my family tons of money by soldering. So, and you're gonna have to solder no matter what, even if it's a kit or not a kit. Eventually, some point you're gonna have to learn how to do that. So again, kits versus 3D printing. And then I've also listed like fundamental that I got from most of the students in here, but you might be watching this like 5 years down the road. But these are kind of like the fundamental websites where you can buy the kits that are fully like parts, and then you can just assemble those. Okay. Now, so let's go back and review the components just to make sure you understand what's inside these fundamental things. Okay. Now, so inside here, you have motors. In this one, you have two motors, and each motor controls one wheel. So that's how you steer. And that's why you're using one of these remotes, okay? Because you can kind of control, there's two options. You can control each motor with one of these sides up and down, or you can program the transmitter with a online source where you can control it with up is straight, down is back, and then you could turn the wheels with this, okay? You have the speed controller, ESC, which this one has a dual motor output. You have your transmitter, which I showed you, in your receiver. You got all the wires. You got the battery, which is right here with the right connector. This is actually a LiPo battery, okay, because it has a balance lead. You could have on and off switches if you want. These wheels right here are made out of TPU, so they're like rubber, okay? So this one, again, I printed the chassis. I bought the screws, the motors. I had receivers, the ESCs I purchased. I 3D printed the tires, okay? We just actually quickly designed those in Inventor, and that's maybe what I'll show you how to do, a quick wheel, okay, for those that don't know Inventor. We talked about brushed. This is kind of like the inside components of a brushed. Here is the components of the brushless. And one thing to note that I didn't mention before, you cannot use a brushed ESC with a brushless motor. So if you notice here, do you see how this is a brushless motor? It has 3 wires. That ESC has to have 3 wires, which is called a brushless ESC. So you got to make sure that you match the brushed system together, okay? And sometimes the motors have a, I don't know if those do, but they have like a torque rating. So like sometimes they'll say like 12T, or they'll be like 30T. So the higher number has more torque, okay? And the lower number, you can actually make your robot go faster typically, okay? So that's one thing to note. And then depending on like the motor size, if you see this is a brushless motor. I mean, it's huge. You want to make sure that your ESC, all right, you can get enough power to make this thing work. Okay. So this is a 90 amp ESC. So I get 90 amps if I wanted to this motor. Okay. Now the brushless motors have what they call a kV number, which is how fast the RPMs are per volt. Okay. If depending on the size, like if it is a higher kV, you may go faster, but you may not get enough torque. Okay, so there's a trade-off on that. Now, the other thing to mention is when you buy your battery, you want to make sure the battery capacity, all right, is big enough. So if I can't use this battery right here with this because this thing does not spit out enough amps. Or on LiPo batteries is what they call a C rating. So in this right here, this is a 2S LiPo battery. It is 50C and it's 5,000 milliamps. So that means you take the 50C and you multiply by 5 because it's 5 amps. That's 250 amps I can get out of this, which this ESC is 90, which this goes with this motor. Like I bought them together. Okay. So I can get 90 amps from this. Okay. That's why you want to make sure your battery is big enough. Otherwise, it just won't spin this motor. Okay. For you guys doing robotics, typically these motors are small enough where these batteries will work. Okay, they have enough juice to make this spin. Okay, now you don't want to put one of those big batteries in here because it's going to weigh it down. So you got to figure out your weight distribution sometimes, and again, depending on one thing I did forget to mention is that's 5,000 milliamps. This nickel metal hydrate is 1,800. So you're pretty much going to get like less than half battery runtime. So this typically on an RC car, like a 10 scale, probably 8 minutes, where that could be maybe almost close to 20 minutes for 5,000. So depending on the battery and the milliamps, it could be bigger, heavier, and maybe that's what you need for the robots. It all depends. All right, again, I talked about batteries. I talked about wire size. So these are places where you can actually go and find things to 3D print, like a very common ones. Some of these you actually have to pay people to get, like Cults. Thingiverse is free. Cults, I think, in printables, you pay a little bit for some files that you want to download. And then there's some other ones here that are you can access. Now, how do you 3D print? Typically what you do is I can kind of show you like a quick thing here. Say we go to Thingiverse, which is commonly where I go. And if I type in Viper Mini Robot, I don't remember the company's name. What's the company name for this? Oh, Fingertech.
I don't know if it'll be on here. I know the file from.
Yeah, right here. That'll work. What's this? Best Western? Get out of here. So say you found something and you want to print it. Okay, you just click download all files. And then it should go to your downloads. Then you have to extract it. Click extract. And then there's a README, there's images, and then here's the files. So depending on like what part of the robot you want to print, you can go ahead and grab that. And let's see. Let's do this. Let's just do this. Let's see what this is. I'm not sure. Yep. So this is just the top of the robot. Okay. And what you can do is this is a program that you download. It's free. It's called Ultimaker Cura. This works primarily, for the most part, with any majority of a 3D printer. Okay. So you could download it. You download this software. You bring this file in here. These are STL files, okay, that you would get. And then what you can do is you can change some printing stuff. And maybe I could do another video just on very basic 3D printing. But you can change the percent infill from like 10% to 100%. And then you can slice it. When you hit slice, it's going to make the code, and then you can save that code to a thumb drive, and then you bring it to the printer and you can print it. Okay. I can do a separate video. I might even have a video that I can already share with everyone on how to 3D print. I'm pretty sure I have one somewhere. But this is kind of like you could print these parts and then start assembling what you need. All right, what else did I have on here that we haven't talked about? Okay. So with transmitters, I briefly talked about a way that you could program certain transmitters. So you can program this one by using this cable right here, okay? So this is USB, that just plugs in your computer, and then this plug goes in the back of the transmitter. Just don't want to break it, okay? You plug it in, and what you can do is, give me a second, I'll plug it in. And I do have a video that kind of goes through this. So I can plug it into my computer, and you can download this, and I have a link right there, the TC config, and you can open it. Oops, I think I got to turn it on. So you download this program from that link, download it, you plug it in. Actually, let me unplug it and plug it back in. And it should. Let me try resetting. It's one thing I did. There we go. So you see how on the screen, the channels like up and down, you have channel 1 and 2 go reverse. And you have all of these. So you can mess around and change endpoints so they don't go so far. You can change like in reverse. So if I click reverse, I can change one. So like up is backwards. Okay. Down is to the right. You can change just a whole bunch of different things, and you can save this. And once you change it on here, it automatically uploads to this. Okay. And I believe I have a file, because I might have messed it up right now, that I saved for this. And I may have to find it, because I think I deleted it. That you would use to get to program with these robots that I 3D printed. So the right stick controls your movement. Okay. Let's see. Give me 1 second and I'll download that because I might have messed it up right now. So let me go to the chat. I just didn't want you recording my screen, so give me 1 second. Even though you can see it, it's not recording it. All right, I think I have that somewhere way up here. Actually, right there. Okay, so I have a file that I've already saved, which is called this. I can open it, and then it should have it controlled. I think, maybe not. We'll check it out. Let me close this. I'll unhook it. So that's how you can actually mess with the transmitter. So depending on your robot and your ESC, you will have to figure out which channel you want it to be plugged into. Okay. And it also depends on the stick. So I can actually plug this in now. And yep, that's good. So I got it. So this is, I think it's reverse. That's forward, that's backwards. This is left, and this is right. Okay. So that is right now is in channel 3 and kind of 4. Okay, because this right stick over here is 3 and 4. And then the last thing, and then we can open up Inventor, you guys can, is say you want to hook up another ESC to a different channel. What you do is, and I'll show everyone here, is you take the controller part, but you cut off the power, the red, okay? Because you only want ground and signal coming out of that receiver. And then you plug it in the channel of your choosing. So I'm going to plug it into, let's try channel 2, okay? Then you also have to plug in the battery to that ESC to power that motor. And you can get it to work, to shut off, to turn on, okay? That could be a blade if you want, okay? Where you turn it on and you turn it off, okay? So that's how you hook up another ESC. And you could do that as well if you have an ESC that only has one output of a motor, okay? You would cut the power off and then hook it up to your receiver because you don't want to have two powers going back into the receiver, okay? It actually could catch on fire or smoke and it will stink like electronics, okay? So you can have a motor hooked up, you could have extra servos hooked up, you can have a shield or something that comes up and down with a servo. So there's a whole bunch of different combinations that you could do, okay? Now, so this is like a very crude, fundamental, like here are the basic components that you were going to need for a robot. I hope that's what you're looking for. What we could do, I would like to probably find a video on 3D printing, like a very basic one. What we can do now is, I won't do it here because I don't have Inventor. But those that don't know Inventor, I don't know, do you two know Inventor at all? Okay, but those 4 are pretty good. I'll come over and just show you what you can do so you can design your own. Okay. Now, what I guess what I guess what's the next step or another workshop that you would want me to do? Okay. Sure.